think it's safe to say that most of us are starting to use ChatGPT on a regular basis in our day-to-day lives. And we've seen a lot of integrations of large language models into software applications. A lot of this is down to the OpenAI API. And in this video, I'm going to take you through an example of how we can build a very simple, rudimentary application that can interface with a large language model, creating a basic chat client. We'll create a console app which allows people to input prompts, and it will send those prompts to ChatGPT. ChatGPT will generate its response, and then we'll pipe that response back to the user through our console application. So first of all, we need to set up our API. And for this, obviously, we're looking at OpenAI for ChatGPT. So I'm in the OpenAI playground. This is a really powerful application. It allows you to interact with ChatGPT, but also set it up in such a way that it's ready for programmatic interaction. So you're able to actually, from your code, interact with the large language model and deal with the response, and also tweak the way that the model processes the data you send to it. So just like in ChatGPT, in the playground, what I can do is say, hello, how are you? And it will respond to me in the same way that it will if I was just using the normal ChatGPT client on the web. The difference here is, though, that we've got lots of different settings on the right-hand side where we can influence the large language model, and we can also choose the language model that we're going to work with. Now, I'm not going to go into too much detail on that just yet. What I'm interested in at the moment is how we actually do what I just did on the screen, but from our C# code. Now, in the playground, there's a handy little area called code, and if I click this, it will give me an example of how I would have interacted with this to get the same result. Now, there's lots of different options here. We can generate a Python script, we can do something in Node. I'm going to go for curl because it will give me the basis for a HTTP post call that I can build in my C# app. Before I get into loads of detail on the API calls, there's a little bit of prep that we need to do to be able to actually interact with ChatGPT via the API. So unfortunately, it isn't free, but it is very, very cheap. OpenAI charge on a pay-as-you-go basis based on tokens. It's a little bit difficult to define tokens easily, but think of them as groups of characters. Every time you send a prompt to ChatGPT via the API, you'll get deducted a certain amount of tokens. I've been playing around with this for maybe 2 or 3 hours, and I think I've used about 2 cents. So it is pretty cheap. The other good thing about the way they've done this is that they allow you to preload a balance. So you don't have to worry about how much you're being charged. You can just say, I'm going to put a minimum of $5 onto my balance, and I know that, once that's gone, it's gone. I'm not going to get crazily charged, and I can keep a real close eye on how much is actually being charged against my balance. So to set this up, you would go over to settings, and then on the left-hand side, you've got billing. And as you can see, I've loaded a very small amount. I think it was $5 that is the minimum. And so far I've used about 2 cents. By default, auto recharge is off. So you won't get automatically recharged once your balance reaches 0. So I think this is, fairly accessible for people that just want to get into some large language model development. It's a pretty small price to pay, and if you were going to then take this forward into a commercial application, it's still allowing you to manage the amount of cost that you've got associated with OpenAI. So then you would add to your credit balance, you would use your credit card, or you would pay the balance in. I recommend just starting with the minimum $5. That should give you plenty of room to explore the playground. So back in the playground then, this is where we interacted with ChatGPT. I'm going to go back to this code section, and as I say, we're particularly interested in curl because this is going to be where we're looking at a simple HTTP REST call into this completions endpoint. So we'll speak to this endpoint, and this is where we'll send in our payload, which will be the prompt that the user typed into our console app, and then we'll also get the response in a similar fashion and output that to the user. So we've got our content type, which is application JSON. We use bearer tokens, so there's an API key that you can generate. I'll take you through that shortly. Those will go into the headers, so curl will define those with a -h, and then inside here, this is where we'll build our JSON payload, and we'll do that inside the C# application. We're specifying our model. We've got an array for the messages that we're sending in. We specify a role when we do this as well. So, when we're passing in information from the user, it will be the user role. There's some other parameters that we need to pass in through the payload as well, which may look a bit odd if you're new to large language model development, but I'll go through them from a high level. So OpenAI needs you to send through a temperature. So the temperature defines how creative the large language model is when it's generating responses for you. So if you lower that temperature, it will become more and more direct. It will become less creative. Now, as with any of these kinds of parameters, it's a fine-tuning exercise. So for now, I'm just leaving it default 1, at fairly high temperature. But if you needed to then lower it so that it was very to the point and less creative in its responses, you could bring it down to, say, 0.5, 0.4 until you find that happy medium. This is fine tuning. So as I said before, in terms of the billing, a token is essentially a representation of a word. I would usually use the benchmark of around 4 English characters. I would call that a token. You can specify the max tokens, so you're able to put a limit on how many tokens can be generated in the response. Be very careful, because if you set this too low, you could end up with a cutoff response. Top P is top probability. It's very, very similar to temperature. It's just an alternative way of measuring creativity. So again, from the same rules we were talking about with temperature, the lower this is, the less creative the response is. I tend to just keep these the same between each other. So temperature being 1, top P being 1. And then as you work through your development and you get responses from ChatGPT, you can tweak this as you need to. The frequency penalty is about how many times the model repeats itself. So if you set this greater than 0 and obviously increasing in amount, then it will penalize the model for trying to repeat certain words. So you'll find that the responses are less repetitive if you set the frequency penalty higher than 0. Similarly, for the presence penalty, it penalizes the model for introducing new topics. So I'm setting these 2 penalties to 0. I don't really want to penalize the model. I want to keep things really simple. But for the presence one specifically, if it started to not necessarily veer off, but introduce new concepts within the response, then that would be reduced. For now, I just want a very simple setup, and I'm going to leave these at 0. And response format is pretty self-explanatory. We're telling the model that we expect a response in text. So that is the default, the classic response, conversational response that we would get from the model. You can set it to JSON, and that's probably something we would explore in another video, because that would allow you to provide very focused responses in a structured format. It's probably a little bit more advanced in the sense that you're having to ensure that the user, I think they have to mention JSON in the prompt, which can be a little bit more difficult to manage. You'd have to sort of force them to use that. So we'll come back to the JSON later on when we need to send through our payload. First of all, we need to look at our API key. So you'll need this to be able to interact with the model. So just as we did for billing, if you head back over to settings, on the left-hand side, you've got API keys. Now I've got my key here. Now the benefit is that you can't actually see the key in here. So you can see a snippet of it, but you can't actually get the key once it's been generated. You see it once and then it's gone. So you have to make sure that you've kept it somewhere safe. And we're also going to load it into the application at runtime. So you would just create a new secret key. You can create a service account, but that's a bit out of scope. But that's out of scope for this video. We're just going to keep it simple and create an individual key. So I'll call it my key. You select a project, the default project, and then you can set different permissions. So you can restrict it so that it can only look at certain endpoints. Again, this is a simple introduction, so I'm going to keep this to all permissions so we can just do whatever we want to do. And then I create the secret, and it will show the key on the screen. You'll be able to then use this in any of your API calls. Obviously then I'm going to delete that key so that, because it's been shown on the internet through this video, it's now no longer usable in my project. So we've looked at the playground, we've looked at the different aspects of the playground, how you can load a balance onto your account, how you can generate a key, how you can get a sample JSON payload. Let's get into C# now. Let's build a console application and we'll start interacting with this model. Okay, so we've got our console application. I'm going to remove the default hello world and we're going to set some fields from the start. So to begin with, we need our API key. So I'm going to just set a private read-only string, which will be our API key, and we'll be able to reference this in our calls. I'm going to put a constructor in for program so that we can load our API key, and I'm going to load it from a file. So I'm going to say that it is equal to file.readAllText, and then I'll specify a file location where I'm going to drop the key into a text file, and then we'll read it in as the program is being initialized. So I've just dropped it into my temp location at the moment. So I can do that in the background. That will be set up, and then I'll have an API key when we start the application. Okay, so I've done some initial setup after removing that default console write line. Let's make that static. And what I've done is I've dropped the API key that I've generated previously into a local text file on my machine, and then I'm going to initialize a field API key to that value. So I'll read the API key from my text file and I'll set it here so that I've got it for any future calls into the API. Then I'm going to create another method. I'm just going to call it run chat loop. And this is where we're going to be actually running a loop which is waiting for input, using that input with the API, and then returning a response and doing the same thing over and over again. So I'm just going to create a bool called keep running. This will be set to true, and then we'll be doing a while loop. So while keep running, and then in here we've got our main logic. So we'll want to receive input from the user. So I'll put var message equals console.readLine. So that will accept or wait for string input from the user on the console application. It will read that into the buffer, and then I can use that to interact with the API. For actually interacting with the API, I'm going to create a class. I'm going to call it OpenAI Connector. So we'll go and add a new class, call it OpenAI Connector. And I'm going to add in the parameters that we were looking at in the JSON example. So the things like the temperature, the top probability, the presence penalty. I'm just going to add those as fields in this connector so that they're added to the payload. So I've added those in as constants, and you can see here we've got the model. So we're specifying a very specific model that we're going to talk to. We've got the temperature set to 1, the max tokens set to all the default values for the other different parameters. I'm also going to add a private read-only string for our API key. And I'll also add another private read-only field, but this will be a HTTP client. Now, this is probably not following the best practices for HTTP client generation, but it's a very simple example. The connector is just going to create one HTTP client. It will use that throughout the duration of the calls in the whole lifetime of the application. So I think it'll be fine for this example, but obviously there are better practices for managing HTTP client with a factory. It's out of the scope of this video. Because we've got read-only fields that we need to initialize, I'm going to create a constructor for this class. So we'll say OpenAI Connector, and we'll take a parameter of API key. So we can pass this in from program.cs, and then we can set our API key field to the argument that was passed in. We also want to initialize our HTTP client at this point so that the class is initialized. We've got a HTTP client ready to go, and we've got our API key ready to be passed into the payload. This client will need to be configured with some authorization information, so our API key, and we're going to point it to the base address for the OpenAI API. So I'm going to create a method called configure client, or configure HTTP client is probably better. And in here, we're going to set our base address. What is pretty crazy is that JetBrains Rider, the IDE that I'm using, has actually anticipated what I'm looking to do, which is amazing to me. This is actually the address I'm looking at. I'm just going to take this bit off because I think I'm going to add this to the client as I make the call. But in terms of the actual base address, this is spot on. I also need to add in the bearer token that we're creating. So that will be with our default request headers. I'm just going to add that in, and the name of the header is authorization. And then as per that example, we need to add bearer followed by the API key. And so there, the response again, the suggestion from Ryder is again spot on, bearer and then API key. So then if we call this in our constructor, then we've configured the client with the base address, we've added the API key to the authorization header, so it's ready to go. This means that we can just create the payload, the JSON payload, as it's shown in the playground example. So we'll want to make a function for that configures the payload, so then it can be used as part of the post call to the API. So let's create a string function called create payload, and this will be based on a passed in message from the user. So we'll have a message parameter, and I'm going to put in a response format so that you've got the option of being able to specify whether something is text or JSON. By default, I'm going to set this to text. So we've got a default parameter here, an optional parameter that we're setting to text. And then we're going to use system.text.json. So I'm going to create a new JSON object called payload, and it'll just be a new JSON object. I need to add a using statement for system.text.json. And I think it's actually nodes as well. That's why it's not resolving that. There we go. So we've got a JSON object. So looking back at the example, we've got the payload here. So we've already taken care of getting these top level fields, temperature, max token, top P. They're fine. We'll be able to serialize those into our payload. It's this aspect that I need to be concerned with. So what I want to be doing is creating an array with a message object. Now we're only going to be passing through one message, so the array will only have one object, but then within that it will specify the role, and then within that object also there's another array that has a content object, and that content object will say the type for the message and the actual text that we're passing through. So we'll be able to easily specify the role, which will be a user, and the content that's going to be sent through. I'm not going to pass in this assistant object because this is just another message object. I don't need to be concerning myself with this because there's no response at this point. We're just dealing with the actual prompt that we're sending through. So I'll put together some C# now, which will build this aspect of the payload. So we've got lots of different objects that are being stored inside objects, which are being stored inside arrays. So bear with me on this one. I'm just going to work through this fairly quickly, but you'll be able to slow it down to look at what I've built as I go through. So the response format is an object. So again, we'll create a new JSON object for that. We had a message object. So that's another JSON object. The message object had a content object. So I'll call that message content object. So I'm just looking at the JSON on another screen, seeing where there are objects within arrays and just creating the equivalent objects and arrays in system.text.json. I'll populate those, put them back together into the main payload and return that. So now we've got some JSON arrays. We had a message content array, which the message object goes into. So again, I'll create a array message object array. Oh no, sorry, message content array. And then we have an actual array for the message objects. So I'll just call that message array. So if I just refresh memories, we've got the message array. This is a message object. We've got a content array and a content object. So just to give you some context as to what I've just dropped onto the screen. So now we can build our JSON payload. Now I'll make this source code available online so it's easy for you to get started. I wrote some code earlier which actually built this payload and dropped the various different data points into each of these objects and arrays. So I'll drop those into this project now and go through them. So we've got message content object add, we're adding the type text and the text of the message content, which will be the message that we've passed in from the user. And then we add that into the message content array. So now we've got a message object insertion. So we're adding a field called role user for the message object. The content will be the message content array that we just updated here, and then we're adding that message object to this message array, and then adding that to the overall payload. So I'm just building up these objects and arrays separately, and then eventually putting them into the main payload. So now we've got this messages field in the payload, and that is an array which has all this information in it. We also had a response format object that we have to add to the payload. So we'll add to that here. So response format object.add. So the field inside that is type, and then we'll use the response format that was passed in from the optional parameter. So by default for us, this is going to be text unless we send through anything different. And then we can add that to the payload. So we can say payload.add. The example showed it as response underscore format, and then it will just be the response format object. So I think that's the most complicated aspect out of the way. After that, we can just add our fields for things like the temperature, all the different parameters from the model perspective that we discussed earlier in the video. So I've just dropped them in here for speed. So we've got the model just added as properties at the top of the payload, or the top level of the payload. And then this function will return payload to string. So that will give us a JSON string. In fact, it's probably better if we use toJSON string rather than just toString. So now we can start actually sending prompts into the API. So I'm going to do this with another function. I'm going to call it prompt. And this will take care of actually building the payload and then sending that through to the API. So I'm going to make this asynchronous as well, because we're going to be using our HTTP client, and I want to be able to await the call. So it'll be an async task. I'll make it nullable, and I'll call it prompt. We'll obviously receive our message from the input on the user side, and again we'll give them the ability to pass through a different response format, but we'll make this an optional parameter. So first things first, we want a payload for our API call. We're going to be doing a HTTP post, so I'm going to use string content. So this is a HTTP format that we can use to take in string and make it suitable for a HTTP payload. And this is where we pass in our JSON. So we can actually call create payload here and then pass in our message. So that will create the JSON string that we've just set up here for the API call. I'll add some further parameters to the string content. So we want to set it to UTF-8 as an encoding. And I'm also going to set the content type, which as we saw in the example is application JSON. So that's our payload sorted. Then we do the actual post. So we can create a result variable, and that will be where we call on our HTTP client that we created. And we'll do a post async. We've already set the base address to api.openai.com. So we're going to be doing it to the endpoint v1, because at the moment that is the version. And then it's chat completions. So this is the endpoint that we're hitting. And then we're going to be sending payload. So that should give us our response or the result of the HTTP call. Then we need to be able to parse the content in the response so that we can pass that back to the user in the form of the actual prompt response. At this point, we want to be able to see the result. So I think it would be a good idea to close off this function temporarily. So we could say return null just to get this to compile. And then we could compile the application, test it, and see what the response is so that we can get an idea of how we would parse that response. So I'm going to put a breakpoint here and we'll start debugging. So I'm actually going to create an instance of our class. So OpenAI connector equals new OpenAI connector, passing in the API key. I'm going to change this run chat loop to an async task so that we can await the call to the API, and then I'll put the result into await OpenAI connector dot, and I think I need to make prompt a public function. There we go. And we'll pass it in the message that was sent in on the console. And then on main, we can call run chat loop. I'll just put an await in front of that. Change this to a task, async. So if I put a breakpoint here where we've received the input from the user, we can then debug. I just need to fix this because I gave it the wrong file name. So it's OpenAI key.txt. Put that there. So let's just make sure that's now working. So we'll step through. We've got our API key. Okay, just grab that last bit. Just have to update that path because it was off slightly. But now, if we debug, we should have the ability to input a message. It seems to have an issue with the string interpolation I've got here. So I'm just going to change this to just be string concatenated. Just to see if that makes a difference. Try that again. Okay, so I did have a little bit of an issue running this, and it was down to the way the key was being read in from the file, because previously when I did this example, I wasn't actually reading from a file, it was in the project itself. What I noticed was the way it's read in from the file, there's a carriage return at the end of the string, which was messing up the HTTP headers. So I've just slightly changed this to make it so that reading in the key from the file, but then I'm just trimming the end of it before I use it. So just bear that in mind if you're also reading this in from a file. So I'm going to debug this, and we should get to the point where we can enter some content. So I'm going to go to our console. At the bottom, I should be able to type a prompt. So I could say, what is the capital of the United States? Send that in, and I get the input. We're going to pass that input to prompt. So I'll step into this. So we're in our create payload function. So we're creating that initial payload. Just run through this, make sure we get everything together that we need. And then we return that as a JSON string. So if we take a look at that payload, well, it's in the string content, so we can't actually do that. So we're going to do the post request so that we can see the result. And then if I look at this, what I forgot to do was to actually parse out the result. But what we should be able to do is go into the immediate and get the result of result.content.read as string async. We'll put a dot result on that so it runs synchronously. And then I'll copy this out just so we get an idea of what the response is going to be, because that's what we're really concerned with. Just bring over a text editor. Now obviously we've got a lot of escaped string characters in here, so I'll ignore a lot of those. But what I want to look at are the fields in the JSON. So what I'm actually interested in is the content that's returned back from the model. So you can see here there's a content field, and that is in a message object. So we've got message, role is assistant, so that means it's come back from the model, and then the content has an object where we've got the response. So the capital of the United States is Washington, DC. So I'm going to use C# to parse this out and return it to the user. So back in the console app, I'm going to create a new function which will be parse response. We'll pass in the actual response from the API. So here we can get the response. So I'll create a new variable called response, and that is equal to await result.content.read as string async. And then we can return the result of parse response, passing in that response. In parse response itself, we're going to create a response object where we actually convert that string into a JSON object. So response JSON node.parse, and then I know the thing we're looking for, the actual string response for the user, is inside this object in the choices property, choices array, sorry, so it's the first one. I'm going to assume that that is there at this point. And then within that, it's the message object. And within the message object, it's the content, which we're then going to get as a value of type string. Now, this is making a lot of assumptions. It's assuming that everything that I'm accessing in that JSON object is not null. So what we could do to take this further in the sense of making it safer, we could make some of these nullable. So we can make sure, if response object is null, or choices is null, or that index is null, message is null, content. We could go crazy with this and just put a lot of safety around it. This on its own, though, is not really enough. What if the whole thing is null? Then we actually want to return something different. So I'm going to put a null coalescing operator there to say if it's null, we actually return our own string. So I can say something like, sorry, I don't have a response for you at this time. So we know that it's always going to return some kind of message that's friendly to a user, even if we haven't been able to get something back from the API. So let's test this out then. Let's debug it again and see if we can put in a question and get a response. So this time I'm going to change it up a little bit. I'll ask for another capital city. I'll say, what is the capital of France? And then we hit that breakpoint. I'll let that carry on. And nothing has come out onto the console because I've been very silly and I've forgotten to actually write out the result. So I can say console.writeLine result. So that will actually present it back to the user, and then it will go back up to the top of the loop. So if we run this again, ask the same question, what is the capital of France? There we go. We get the result, which is the capital of France is Paris. I'm going to get rid of that breakpoint and try something else. So I can say, who was the first president of the United States? And there we go. The first president of the United States, George Washington. So we could ask it a slightly more long-winded question. We could say, what is the difference between Java and Python? It should take a little bit longer to formulate this response. And one of the things that we haven't actually built into this is the ability to show the scrolling text that you would see in a traditional, if you can call it traditional, ChatGPT client. So we've had to wait for it to just get the whole response and dump it into the console. But you can see we've got quite a lengthy response here, talking about the difference in syntax, the type system, the performance. And so now we've got a basis for an application which can interact with a large language model. So this could be just a very small part of a wider application where you want to actually allow people to interact with ChatGPT. And also, OpenAI have started to allow people to use their own files. So you'll be able to expand this even further and use your own data as context for your large language model app, which is something I'd more than likely do a video on later, so that we can go into more detail around how we can improve these applications. But this is a very basic introduction to adding ChatGPT to your application or communicating to the large language model using C#. So I hope you found this useful. I've loved working with this. I'm really excited to go further and actually start building more intricate AI use cases, building it into web applications, desktop applications, serverless functions, all that sort of stuff. But until then, don't forget to like and subscribe to the channel for more great .NET content, and I will see you in the next one.